weeks that I'm in Hawaii. And I'm like the kingpin of the biggest carpool, and you're missing 5 because they won't do it without me because I'm the furthest from. Well, talk to them about doing it without you because we're always going to survey at a time when somebody's out. No matter when I did a survey, some group would come to me and say, "Man, it was weird. This week I couldn't do it because of a doctor's appointment or something." But the good news is we had reached that culture of people wanting to carpool and feeling like they were contributing to the goal, right? That's the genius of the LEED EV rating system, all right? That's its purpose, is you can pick at all of these separate issues of sustainability one by one, or you can have this complete skeleton on which to hang all the issues because it all works towards a singular goal of gold certification or platinum certification, right? If you're goal-oriented. Clearly I'm goal-oriented. So these are where we picked up the extra trips. Same exact number of fuel-efficient alternative fuel vehicles. People aren't buying, they're not so committed that they're saying, okay, I gotta go buy a Prius. But we did see an increase in telecommuting and a slight decrease in compressed work week. That's just one person based on that week. Self-powered mode went up. I'm inside that bar. I decided if I only live 2.5 miles away from work, why can't I commute more regularly on bike? So Matt and others in the firm kind of put on some seminars and said, this is how we do it. These are the, it doesn't have to be gear intensive. You can ride on an old cheap bike and it doesn't have to be, a snobby thing at all. It can be a commuter mentality to bike riding is not the same as a recreational mentality. And I was able to get into that. Public transportation. This is a leg on Frontrunner showing up that somebody was trying their best to figure out a way to make it work. And carpool, vanpool is where we got most of our increase. I suspect most of your businesses will have the same thing. Trying to get people into this category is a challenge. This is much easier to get people to do. Water use reduction. This is the locker room compartment in our toilet, shower, laboratory locker room compartments of the men's room. This is the men's shower area. That's Bally's Fitness. The use of the building just before us was a Bally's Fitness. So again, a sustainable decision that we made when we were designing the facility was not to undo that. We just kept it. We had to scale it back. The locker rooms were huge in a Bally's Fitness. So we just cut about half of it out, turned some of the lockers around, surplused a bunch of other lockers to our staff who wanted to have some at home in a garage, and now we have this. And so this is critical infrastructure to making the active transportation work. The reason it's here is a segue from transportation to water use reduction. We have very little building water use in our office. It's toilet flushing for the most part. And we run the dishwasher 3 times a day for reasons I'll see in a minute, and I'll show you in a minute. And there's just not a lot you can do. Nonetheless, Spencer's group made sure that we had maximized our lead points there. It's 36% building water use reduction. That's great. It's not a significant contributor to water use reduction. Our water use in the outdoors is much greater than in the indoors. So this presentation mostly focuses on the outdoors. This is the view. My office is on the other side of the wall. I look down the tube of that open courtyard that I mentioned before when I showed you the site plan with where we took out the roof. This is a beautiful landscape inside the building. It's an outdoor landscape that uses very, very, very little water. So when I talk about low water use landscapes, I don't want you all thinking about, like red lava rock from the 70s, and cacti. That's not what it looks like. It looks like this. My wife sometimes will ask me on the way to work, she'll say, well, so are you going to the spa today? Meaning, do I get to stay in my office or do I have to go out and visit clients? The best days are the days when it snows. It's just awesome to see snow falling inside the building. All right, so the blue bars are, I guess I gotta back up. Anybody who's at all familiar with irrigation systems probably has heard the term ET before, evapotranspiration. So there is a massive amount of science going into how much water is actually needed on a landscape that includes the soil type. Sand lets water through, clay holds water. The plant types, native and adaptive plants, need less water than plants from tropical jungles, right? Et cetera, et cetera. The temperature, the wind speed, it's very complex science. But we have a smart controller, all right, smart irrigation controller with a weather station that watches and learns about the environment around it. And it calculates the blue bars and says that's how much water you need according to science. And then the green bars are how much water we supplied. in practice, the actual water. So the space between the top of the blue bar and the bottom of the green bar is the water saved. That's how the leak calculation works. The distance between the actual application and ET. So that's a lot of water savings. It's probably a little too much. We saved 88% over baseline. So if we had just watered according to science, we would have used 88% more water. It's not a substantial amount of money in Utah, unfortunately, because water's so cheap. But it is, thousands of gallons of water. We did see some strain on our plants in July. We did find the performance period was from April 1st until July 31st. You have to include July in your performance period for irrigation. They make you use the worst month for that. And we started to see mid-July. Remember last July? This was 2013. It was really hot. Some of the plants started to get a little squeamish. And I started to get nervous, but we stayed the course, made it to the threshold for the points we wanted. And in the end, the landscape architects in our office, their opinion is it just makes, what doesn't kill them makes them stronger. They'll have deeper roots, they'll be more resilient, it'll all be worth it. That was a little hard to face the president when all the plants were looking like they might die, but it worked. Our landscape architect, Austin, is so good at this. I know you can't read all the words. I'll tell you, the first line is, this is a particular phrase. He's so good at this and enjoys it so much. It's his, like, EV's my passion. Well, water use reduction is his passion. He's actually monitoring several of our projects for clients too. So it's turned into an interesting revenue source to be able to say, well, now this red word here is mainline break for the LDS church at this location. So he's kind of helping them manage their irrigation systems in a few locations. This is a water reuse roadmap that I put up here because I told you we're not doing a tremendous amount when it comes to building water use, but I'm interested in doing more, and I'm interested in constantly kind of maturing my perspective on issues. So I worked with a civil engineer who's not here. I don't think Laura Vonage is here. And I worked with a plumbing engineer, Spencer Regan, and myself. We kind of tried to figure out the regulatory climate for water reuse in buildings in Utah. This is not an original concept. We borrowed this from a study that was done in Oregon. And anywhere where those flow lines go red, there's a regulatory prohibition to using water that way. Anywhere it doesn't go red, you're allowed to do it. So there's a lot more ways you can use rainwater and gray water in buildings than you think. It's a lot more legal than you expect. And I've been meeting regularly as part of my P3 role with folks from Department of Water Rights, Water Resources, Water Quality, et cetera, to see if we can get this perfected. And Spencer, I've made one change in the 3 years since we did this. And it's so subtle it just took a couple of words. It wasn't a graphic change. I will find people who tell me this is not possible, and then we'll go through it and they'll say, okay, yeah, that's possible. So it was good work. But the reason I hold it up here is now that we finished our double platinum exercise, I want to go through a net zero water exercise. Not that I think we can really be net zero water on this particular site, but I want to go through the exercise again. So I'm going to learn on me before I inflict it on you, right? That's the idea. Energy use reduction. These are what we call our infographics. Okay? So there's a couple copies up here of other buildings. This is at the end of an energy audit. Here's a level 2 energy audit report for the Mill Creek Community Center that we designed, and it includes just a tremendous amount of information, like stuff you won't see today. Lighting analyses. Red's bad, green's good. Okay. Trying to figure out ways to save energy and save money. This is like a graphic executive summary of that book. That's the idea. And so for our own EV effort, we had to create our ASHRAE level 1 and 2 audit work. And on the left here, you'll see the EUI of where we were when we started tracking on Energy Star. 70 is a decent EUI. It's a respectable EUI, but it's not setting the world on fire. And where we need to be by January 1st of 2015. And then in the corner here, there's a glide slope to get us there. So we track monthly, every month, to know how we're doing. And that's our current Energy Star score. The green, these are little cars, if you can zoom in and see it. These are little cars. These are our emissions in single occupant vehicle equivalency. And these are the cars we've taken off the road compared to national average. So we have all those metrics. Before you try to save any energy at all, you have to start with an occupant comfort survey. All right? At least in an office setting, that's true. Might not be true in every setting, but in an office setting, it's essential. Because the easiest ways to save energy drive up discomfort. It's that simple. Okay, so you've got to know how you're performing. This is an example from one of our thermal comfort surveys. You can see people tending towards a little bit cold. That's just generally true. Right now my hands are cold. I don't know how you guys feel in the room, but I'm a touch cold myself. And so you need to know which part of the energy use spectrum to affect in order to make sure that you're not taking energy away from the wrong spot. These are some pictures of energy audits we've conducted. Normally, so when I was working with Varian on their energy audit, there's 3 pictures here of their equipment. These are actually 3 different energy audits. Our building equipment is so mundane, there's nothing I can show you. It's literally a couple of commercial water heaters, which don't look that different from your water heater at home, and a bunch of rooftop units. And so this is the boiler from the Draper Library, the single most out-of-place piece of mechanical equipment in a commercial building I've ever seen. It's a residential boiler, and it was a piece of crap the day it was installed, and now it's 10 years later, and it's not only a piece of crap, but an obsolete piece of crap. This is Varian's manufacturing area. These are all LED lights. So, they have been very proactive about changing out and reducing energy and saving energy in their production areas. And that's a very good example of a lighting solution. And here, anybody tell me what it is about that picture, why I took that picture? It's not because it's a computer, it's because of something else. Screensavers are evil, right? Turn them off. You don't need them. It is not 1995. They have no place in business. Get rid of them. They're taking a tremendous amount of energy away. You're putting money into a screensaver and then out a smokestack. It's a waste. Turn it off. That's in a library. They were using screensavers everywhere, and their excuse was, if a patron approximates a computer, they need to know what's on. Oh, really? You don't think they'll figure out to wiggle the mouse? They don't have that problem at home? Well, probably not, because they're not using their screensaver at home, but they'll figure it out. All right, another way to save energy, and this is our own tracking. We installed submetering, end-use submetering. The only way you can get this kind of a graph, all these colors represent different end uses, and we'll talk more about that later. But red is heating, and then you've got server plug load. It breaks it down. To know how you're using the energy to affect change, you have to have submetering installed. And so this is the submeter for about half of the office plug loads. Plug loads are like your computers and the stuff you have at your desk. So it's not the lighting, it's not the HVAC equipment, it's not building system level stuff. It's users, it's occupant stuff. And so you can see every day, this is a month, okay? You can see every day there's a spike, and every weekend there's a low. But the low, this number over here, by the way, is 576 watts. All right, so it's not a very big number. That's the bottom, but it's still a number. This is about 1.2 kilowatts, okay? And so you can see the normal behavior weekend after weekend is that, yes, people are not using power, stuff is turning off, that's good. But here's July 4th, okay? So I sent an email on July 1st, and I said, all right, everybody, we've got a unique situation. 4th of July is on a Friday. So if we really got serious about this, and you did what you're supposed to do every weekend and turn off your computer, we could drop our baseline usage much deeper than we've ever done it before. And we could see it. So let's see what the difference is between our normal utilization on a weekend and on a holiday weekend. And then people were pretty diligent. You can see it's not 0, it's still 576. Ricky's computer was still on. That guy is so green it hurts, but he won't turn his computer off. It's the weirdest thing. But there's money. And then if you take that delta, and you times it by 52 weekends a year, you're talking about money. You're talking about energy. You're talking about pollution that you can eliminate. And then the next Monday, you email everybody that back and say, look what you accomplished. The new baseline is somewhere in between those. Behavior is permanently changed. Knowing, just seeing the information, all right? Honestly, even skeptics want to know. Sample energy efficiency measures, you have to do all of these. You have to do everything you possibly can to save energy, to push your points up in the EV. So think about everything. Solar power, it's expensive, but it's worth it. Optimize your HVAC controls. This shows 74 on here for a reason. If you think 72 is the appropriate set point at all times, you're wrong. The Society of HVAC Engineers says it's wrong. 72 is not the answer all the time. You can widen that band out. so that you should be able to be comfortable being a little colder in the winter and a little warmer in the summer. Why? Because you live on a planet that has natural variation. We don't need the machines to make it perfect all the time. Something that we do that's really unique, we did for ourselves first, and now we've done for several clients, is to conduct a plug load study. The purpose of a plug load study is to show people exactly how much energy they're using where. So this is a watt meter. You can buy it for $20, $25 at Home Depot, when we haven't bought them all up. Right now they're out again. And this is a smart charging strip, and this is that computer with the power saver features, or sorry, the screensaver turned on. And we're able to do an analysis that shows what the average workstation uses in watts, and then multiply that out across the number of workstations in a facility, and then multiply that across the amount of working days of the year, and then say, okay, so what do you want to change? Let's assume you just want to enable power saver features. We discovered 40% of computers have power saver features enabled, so there's 60% of them that are just sitting there on all the time. If we could get those people to turn them on and not disable them, this is the dollars, the watts, the kilowatt hours, and dollars that you save by turning them on. And it all comes from showing the number. You see that the same thing happens on every one of these initiatives. I've got to show people a baseline, and then I've got to tell them how to change, and I've got to ask for their opinions on how to change, and then work towards change. And then repeat, 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 repeat. Sometimes use peer pressure, and sometimes use intimidation, and sometimes use praise, and sometimes use, whatever. But you have to rotate through strategies. But until you have a number, you can't know anything. This is at the Mill Creek Community Center. This is a vending machine. It uses 10 times the power of, they have obsessed in that building about buying Energy Star equipment. I am so impressed. None of my buildings has ever been treated that well by occupants. There is not a non-Energy Star rated item in the entire building, except for the vending machines. Why? Because Energy Star doesn't rate pigs. Okay? It uses 10 times the power, and it never turns off, and it's on all the time. So it's actually more like 20 times the power, right?
20 times the power of what?
Of a computer. The average computer in the building. So they've got just, a library is just full of computers these days. And they've got those down to 80, 40, 60 watts for the most part. So they suddenly got really interested in Vendmiser tools and timers, and maybe in our office, we tell everybody, take the lights out of or just disconnect the lights from your vending machines. There's no reason for you to be paying energy so you can advertise for Coke. Just disconnect the lights, and then get them on a Vendmiser, or in our case, Matt was able to figure out a way with the electrician to get them onto the lighting relay, so that when the lights are out, they're already managed really well by a smart lighting system. The vending machines are off too. And in the case of a Coke machine, there's enough thermal mass in the soda that it doesn't change temperature overnight in a meaningful way. Of course, if you have perishable food, I think you have a different problem. But if you're in an environment where you have to buy your lunch out of a vending machine that's perishable, then that's a different set of issues altogether. You probably should have a cafeteria program or something. There's another screensaver. All right, screensavers are bad. Here is an experience I had at the Mill Creek Community Center. This is the library manager's computer. And so I just over and over again in the library, it was if it was a public computer, the power saver features were correct. But if it was a private computer, an individual's computer, they had disabled them. So I go to the library manager's computer, and it says, okay, cool. I'm going to automatically balance performance energy consumption. That's great. And I actually walked away, and I thought, there's a layer behind that. I better go check before I finish this part of the audit. Click. Yeah, behind that, it was never. Don't turn. So they had disabled the automatic features that come with the computer. Literally manually overrode it. This is an example of something I want to implement in my business that I haven't implemented yet. At the Mill Creek Community Center in the recreation area, those guys were on it. All of their power saver features were enabled, and all their screensavers were disabled. They a very efficient group, and on their copy machine, their big floor copier, high volume copier, there's software on the computer adjacent to it. This is scheduling software. So everything that's pink there runs in Energy Star power saver mode, right? So if you walk away from it, it turns off the displays and all the little LEDs. And if you leave it for 15 minutes, it powers down the fuser, and right, it saves lots of energy. So in pink, it's saving tons of energy. In green, it turns it off. It says, I know, I have a schedule. I'm not going to be here at 1 a.m. You can just turn off. And it does it automatically, night after night, without a human having to remember or mess up. I want that on our next set of leases for doctors. High performance office areas. This is a proportional analysis that I like to show to remind people that it really is the occupants that matter in buildings, not the building. If I have, this is a hypothetical building with an EUI of 74.4, kind of resembles my building, right? Ish. If the hypothetical building has, I don't know, a little bit less than a third of the energy being used by the HVAC system, and a little bit less than a third of the energy being used by the lighting system, and about a quarter of the energy being used by users, and you make that building turn it into a high performance building, and you shrink the pie, right? Now you've got a LEED Platinum building that's got optimized HVAC and optimized lighting, but you don't change the energy usage of the users at all. It becomes half of the pie, all right? So every building owner out there that's got a LEED building is sitting over here, right? You should optimize your building first and then optimize your users. However, optimizing the building means capital, right? It means lots and lots of dollars. So this amount of energy is the same amount of energy. Attack your users. Save money on the way they use the building. I know it's not easy because people are resistant to change. And the item at the bottom is highlighted because skepticism is the most difficult to combat. And so I actually rule out skeptics. I don't worry about the skeptics. If somebody has decided that they don't want to change, just let them not change. Go focus on the fat part of the bell curve, the people that really want to change. That's the goal. And that's how we did it at our office. That's how we've steadily driven up driven down our EUI and driven up our Energy Star score. This is, again, the watt meter in use. Now I'm switching over to renewable energy. Last topic in energy. We were working on a project that needed to have a very large PV array on the roof for energy offset. And that very large PV array is something you start to see showing up in high performance buildings over and over again, where they kind of just butt the panels side by side. And those arrays are really sensible in LA and in Phoenix, right, where there's no snow. But you put this kind of array 6 stories up on a roof with snow, and then it catastrophically sheds and kills people on the ground below. That's not sustainable. So we did a research project for how to hold that snow in place without it, because the answer is always like, Matt and I also worked on the Park City Hospital, and massive amounts of snow. The rule on a cold roof is hold the snow. Don't let it fall. Hold it in place and let it melt in place. So bits come off instead of catastrophic shed. And the way you do that is you put snow melt heat tape on the edge of the eave so that it's always melting at the edge, right? And then diminishing in bits instead of catastrophic. Well, if you're working on high performance buildings, you want to put a bunch of energy, right? You're going to spend $1 million on PV, and now you're going to spend some of that money or some of that energy back on heat tape? No way. You got to figure out a way to passively deal with the problem. And so we, Peter, this is great that everybody's here. Yeah, Peter's here. Peter drew this in SketchUp and said, this is a way for us to create some modular racks with 2x4s we can buy from Home Depot, and big enough that when we're done, we can put these in the back of a pickup truck or in the back of a U-Haul and move it around to where the snow is. Because we came up with this genius idea that we were going to do this actual real-life research project when it was nearing the end of the snow season in 2011. And so we said, great, how about we buy some panels, use it for research, and then put them on our building. And then we actually got a third moment in between where we took them up to Alta Ski Resort, took them to the snow. And Alta said, I called Mara and I said, hey, listen, we need to use some, it could be dangerous, people could ski into it, we got to figure out how could we do this? And she made it awesome, just made it work. And she said, and all she asked in return was that we loan her the panels for a season, for a summer, so they could move them around different locations so the Forest Service could approve installation locations because of glare, and right? They're considered an eyesore by a lot of people. And so we bought them, we studied the snow slide effects on them, and by the way, we have the answer, and I won't give it to you. Hire me and I'll tell you what it is. And no, I'm serious. This is an expensive research project. And then we installed them. And in between, they moved all around Alta Ski Resort, which is I think that's sustainable. So back to the end use chart. One of the things you don't hear me talking a lot about is this big red section. So I'm going to get to that in just a minute. There's the detail year by year on our progress. Without getting into the nuances, architecture is a volatile business. And some of what you see here in dips and dives have to do with numbers of people. And there's been a recession, if you haven't heard. So it's, to some degree, we're kind of victimized by our number of people, which makes me worry because I actually think we could be on the way for this, going the wrong way on our trend. So I have to be proactively thinking about staying 2030 challenge compliant. I've got to figure out more ways to save energy, even though we've been over it and over and over it, and we have high performance occupants, and people are totally committed. How are we going to do it? This is how. This is a normal workstation in our office today. 400 watt rating, average usage 150 watts. That's meant, this is labeled on the back of the computer. That's what it's rated up to. This is when I stick a watt meter on 20 computers in our office and divide by 20, add them together and divide by 20, I get 150 watts. This is what we're going to. All right, so here's what you need to know. This answer isn't an answer for everybody. This is called a thin client. So this is like going back in time to the 60s when there were terminals and mainframes, okay? So in this case, the mainframe is called a blade server. Have you guys heard about this before? Okay, blade server is just another device that fits into a computer rack. It's about this big, it uses about 120 watts, and it has, one of them is a SAN, a storage area network. It's just got tons and tons of hard drive space on it. So you don't have to have hard drives here, you have them back in the server room. Another one is nothing but brains, just full of CPUs. They get checked out remotely. So it's distributed computing power. Another one is RAM. Now I've got these 3 units that can do all the work of the 100 boxes like this that are all 400 watts. Now, if this number is 100 watts or 80 watts, you're like the library, you're already on high performance computing. Okay, so this number say 100 and this number is 30. Let's say you're already using a really energy efficient laptop. Then switching over to this isn't a big enough net change to justify it because you are putting energy use back in the server room. So if you have graphic workstations like we do, it's a no-brainer. The delta's huge, right? If you are just doing a little bit of word processing in Excel, this probably isn't an option for you. Really good low-hanging fruit for us, not so much for many businesses. Yes,
what about the increase from the blades?
That's my exact point. Is this delta has to be sufficiently big enough that you can accommodate the increase in blade server. In our case, with 400 watt workstations, 100 of them, it's an easy change. Again, if you were at 100 watts here, I'm not sure you could. I think it would just be moving energy from location to location. Thermal imaging, I showed you that over half of our energy use is coming in the form of space heating. I also showed you that we have a thermal comfort survey that says we have an issue with thermal comfort in the winter. We have to be really careful to not dial back our operational settings in the winter and cause further disruption with productivity at that time frame. So, using our FLIR camera, we've gone around and tried to look at the problem points. This is, again, we reuse an existing building, right? And so we weren't as mature on these issues of sustainability at the point that we were engaging the project, and we didn't think, nor did we have the time, frankly, but we think about that north wall. We have an existing north wall that already had sheetrock on it, and in places we weren't going to touch, like in the locker rooms. We didn't take the tile off, we just left it there. It turns out that wall's uninsulated. Blue is cold, and orange is warm. So you can see that north wall is cold. What does that mean? Thermal transfer is going out that north wall constantly. The entire north wall of the building, which is very long, is uninsulated. And so we need to progressively pop holes in the top, blow insulation in, close it back up, and kind of just do that room by room. And what stopped us is the fact that most of the exposure is actually in locker rooms with red tile. And so that makes it all the more difficult because you can't get a match, and we're obsessed with matches. But we've got to tackle that. Our envelope is the place we save energy to, again, get us back on the glide slope. This is a really incredibly cool feature. There is I know it's very difficult to see, there's a window here, a clerestory window, continuous window goes atop this really beautiful red concrete wall. And the concrete wall is the same wall inside as outside, which is super cool if you're in Santa Cruz, California, right? And it's the same temperature inside as outside. So what did? We put in this giant thermal radiator that just sucks or pushes heat in and out of the building because it looks good. I wouldn't make the same decision again. And above it is even worse. We think the contractor, they were also under the gun. I don't fault them at all. The contractor, we think, left the blocking out here. Above a window, you're supposed to have closure because when it's really cold outside, you can just feel the cold air dumping in. You can see, not only is it a cool color, it's black. It's the coldest thing in that entire picture. So we're actually the building managers and myself are going to come in the summer, see if we can figure out how to disassemble the soffit. There's a really cool metal grill there, and see if we can get that repaired ourselves this summer, because we're wasting a lot of energy there. And every door in every building is a major energy user. These are pictures of Arian's building. I wanted you to see the difference. Look at the spectrum here, 58 degrees to 80 degrees. That's the spectrum. Look at this, 78 degrees to 235 degrees. These are pieces of equipment. Varian manufactures X-ray tubes and X-ray and digital X-ray equipment, and to do that, they use every technology that man has ever invented. It is the coolest place. Giant furnaces, and they've got. So trying to figure out how to help them save energy is interesting because this is part of production. You can't say, well, just run that less. I'm sorry, our business is to make X-ray tubes. It's sustainable to be in business and to give people jobs, right? So the point behind this is to say, every building has a different profile. This building has got tons of heat sources in the building. So they don't have a heating problem, they have a cooling problem. Okay? Everybody's different. All right, waste reduction. How am I on time? What's my deadline?
4 minutes ago?
Oh, okay, I'll go fast. Consumption reduction. All right, first thing is to be cheap. Don't buy in bulk. Stop going to Costco. Costco is bad. Power saver features good. Screensaver bad. Costco bad. Okay, if that's all you get from this, leave with that. We have China dishes. Okay, it's more dignified. It's more humane. Clients feel better. People feel better. Use more water. Okay, but we spent like $300 on dishes, paid for itself in about a month and a half on disposables. Disposables are so expensive. What a waste. That's also waste reduction. Okay, this is the computer if you want to jot something down. Those are the big clients. Our IT guys have obsessively thought about which big client to buy. This is EP rated. EPEAT is an alternative to Energy Star. EP rated. 8 watts, average use. I put 10 on the slide so it looks more convincing. Sustainable food purchasing. We get the majority of our food from Roots when we cater. Roots is the only restaurant we engaged. We engaged dozens of restaurants that was authentic about their claims to sustainability. And I'll name names. Liberty Heights, no authenticity. Would not send us a single bit of proof that they were serving organic or regional food. The biggest shammers of all, Great Harvest. They finally admitted there is not one sustainable bit of food in their entire pantry, not one. Roots ranges from 78 to 90% depending on what we're buying. And proof, here's the picture of the bacon that came from Minden, right? And we know where the food was raised and who by, and it's farm to table mentality. Waste stream audit. This is our waste stream audit. Those are my kids. Yep, I forced them to cut through garbage with me on a Saturday. You can see the bulk. What we do is we create real-world bar charts of waste. This is our paper. Obviously, architecture firm paper is the big deal. I have to move quickly. I apologize. Over 75% of our, or actually 75% is diverted. What we found was there was a lot of missorts going on. We were able to correct that using the metric. Composting is something we started doing as a result. The great thing about composting is it's heavy, it's full of water. So it really helps you with lead points because it's heavy. It's all done by weight. And here's a video you just have to see. This is the waste stream audit we did at Mill Creek Community Center. So if you're wondering exactly what a waste stream audit looks like, this is it. One pile is landfill. One pile is diversion stream. So that you have to have everything tagged and labeled before you start the audit. It's 24 hours worth of waste. So 2 days before, they empty every can out, then they get 24 hours worth of waste, then we go through it, and first thing you do is catalog it. I'm with the laptop, catalog the waste. We found residential bathroom scales lie to you. If you step on the scale repeatedly, it starts giving you the same weight, because I don't know why they do that, but they do that. So you actually have to have 2 scales, and you have to have 2 people shuffling between, you have to have 2 tears, and it gets kind of complicated to do it, because you'll just get the same answer after the 3rd weight on a scale. Then after we've logged everything in, you can see us starting to figure out, well, which stream do we want to put where, telling everybody what to plan for, wear your rubber gloves, don't deal with biohazards, all that stuff, and then we start picking it apart. So what's interesting is this building is twice as big as our building, but generates exactly the same weight of waste. coincidentally, both of us were just about 100 pounds of waste a day. And paper is still their biggest stream. But the reason there's all this stuff there's a bunch of stuff out of back here that's kitchen waste that's really heavy. So they really have less waste by volume, but they have a lot of it because they have a commercial kitchen in the building, a cafe. And then we start picking it back up, and each stream gets reconsolidated and weighed again. So then we know exactly how much paper there was, and how much aluminum there was, and how much compost there was. And then a final sort happened where mis-sorts were accounted for. Oh, then we discovered we missed a bag and we had to go through it. Oh, really cool story. We found a lady's wallet. So somebody got their wallet back thanks to sustainability. But they're a public facility, and so they're not recycling nearly enough. Okay, you can see they're not quite to 50%, so they've got a lot of work to do. It's hard to do when you don't have people in your building that have a shared stake. Green cleaning is the smallest section. Just a few slides left. I apologize for going late. Green cleaning, first thing to do, daytime services. Stop treating your cleaning people like they're elves, right? They should come after the fact, after all the important people have gone home. We have our cleaners come during the workday. Number one, they don't turn the lights on and run them, right? Number two, we know who they are. It makes something more conscientious if they dump a bunch of, the chads out of a 3-hole punch. They know Carmen. And they're like, well, should Carmen have to clean up after me, or should I do it myself? It makes you more responsible. It's a social equity issue. Concentrated solutions, non-toxic cleaning products, recyclable packaging, HEPA filtered vacuums. It's all, recycled paper products. Green Seal approved. If you want an easy answer on green housekeeping, make sure the cleaning products you're buying are Green Seal approved. And the reason that matters is human health. Okay, we're talking about they're not chemicals, they're toxins. Okay, you can't have them in you. They harm you. This is an initiative about building material toxicity. That if you're an architect and you want to know more about this, we should talk because of my Living Building Challenge role. All right, so what are you going to do? What did we do? We use 20-year simple payback as our criteria for our EV effort. This is the EEM list. These are all of the specific things we chose to do in terms of energy to study, to compare. This part of the chart shows energy savings. This part of the chart shows capital improvement costs. And this part of the chart shows financial analysis. So zoomed in for you, green items meet the criteria, orange items don't meet the criteria. At 20.3 years, expanding the PV array on our upper roof was a good payback. 20 years doesn't work for a lot of people. For us, it worked. At 39.4 years, we decided replacing our piece of crap daylight sensors we got in the original building, which just wasn't a good value. Couldn't save enough energy for us. We're already spending so little on lighting that it just wasn't a good payback. Oh, this is Draper's. The Draper Library is a known poor performer in the Salt Lake County Library System. This is their energy use breakdown. You can see we targeted $20,000 of savings a year. This is their actual energy use. This is what their pie would be like if they were a national average performer. It's so easy to fix Draper. All you have to do is get them to be average, and they save $20,000 a year. That's how much energy they're wasting. They had a rule for 5-year simple payback, and that's their light slope. They're doing it. So by my estimation, they save just over $10,000 a year in stuff they've done. And here's the important message here: 0 capital improvements, 100% behavior and operational adjustments. No money other than what they paid us. My fee had to pay back in 5 years too, by the way. That was the criteria I was given by the director. This is Draper. Now it's important to see these together. This is Draper. This is Mill Creek Library. This is the project we did. And this is Harriman. Anybody from Edwards and Daniels, EDA here? EDA should be congratulated. That is a very low EUI for that building. The Harriman Library is stupendous in its performance. This is a LEED Platinum building in Salt Lake that shall remain unnamed. The design team said, when they got their Platinum certification, they said, we'll be here. And they're here in actuality. Just because you have a LEED certification doesn't mean you have a high-performance building. But I can get you there. This is Draper. This is every single library in the Salt Lake County Library System, system-wide comparison. This is Harriman. This is Mill Creek. By the way, Alex is here with the contractor that built Mill Creek. Good job. She was a project manager, and the building performs very well, only a little worse than we expected it to perform. Definitely within the range of getting there. Although I'm having a problem with diffusion where there's 3 departments, they all point at each other as the energy pig, and I'm not getting the traction I want there. Draper, that we thought was the worst performing building in their entire portfolio, is here. And there's Riverton, and I forget what else. So, you know, you need to understand, you need to benchmark your buildings to understand what the energy use is so you can start implementing change. In other words, spending any more money here at Mill Creek is foolish when you can be spending money here and gaining savings faster. These are all the organizations that helped us achieve the double platinum certification. It really does take a village, and I'm going to leave this up because if you're looking for a sprinkler supply company, or you're looking for a recycling agency, or you know, a food place, these are the people that did it. Sorry I went long. If anybody wants to stay for questions, great. If you want to run out, my feelings won't be hurt. Thank you.